Alright, so for the final question, we have, using the definition, find the derivative for the function f of x is equal to the square root of x minus 2. So, using the definition, what it means, using the definition of the derivative, we need to use this formula right here. That is basically the definition of a derivative. So, first off, we want to find out what f of x plus h is, because we already know what f of x is, that's a given. So to find f of x plus h, we simply just plug in x plus h to where you see x, so we get square root of x plus h minus 2, and then f of x is known, it's given to you, so it's square root of x minus 2. So now that we have those two things, now that we know what those, variables are now, we know what to plug in. So x plus h minus 2 on the top minus parentheses square root of x minus 2 over h, of course. Now, after this, we can distribute that negative symbol in front of x, square root of x minus 2. That's going to leave us with square root of x plus h minus 2 minus square root of x plus 2 over h, of course. And then we can see right away that we can cancel out those 2's. And then that's going to give us limit h going to 0, square root of x plus h on the top, minus square root of x minus square root of x over h. So once you get to this point, there's not much you can do except multiply by the conjugate to get rid of the square roots. So that's exactly what we're going to do. So the conjugate of that, of the numerator, is going to be square root of x plus h plus square root of x. So you got to multiply by the opposite sign. As you can see on the left is minus square root of x, but we multiply by positive square root of x. That's going to give us limit h going to 0, x plus h minus x over h times whatever you just multiplied by, which was square root of x plus h plus square root of x. And then you can see in the numerator that the x's cancel out. So now we have limit h going to 0, and at the top we have h by itself. On the bottom we have h times square root of x plus h plus x. Now we can see that we can once again cancel out the h from top and bottom. That's going to leave us with limit h going to 0, 1 over square root of x plus h plus square root of x. Let me rewrite this. Square root of x plus h plus square root of x. There you go. Now we can see that if we evaluate the limit here, we're not going to get a 0 in the denominator, which is a good thing. That's what we wanted to do. That's what we want to do with all these limit problems. So we evaluate the limit, and we get square root of x plus 0, which is just square root of x, plus square root of x. So you have 2 square root of x's on the bottom. So it's going to be 1 over 2 times the square root of x. And that is your answer. There you have it.